All right, we need to be able to simplify exponents here, so we're just going to go through a couple of examples showing the different level of questioning that could be asked. So, the first set of parentheses I see is going to be, or excuse me, the first problem is going to be quantity of 5x to the fourth all squared. So in situations like this, I actually do want to use the properties of exponents. In order to do that, though, I want everything to look like it has an exponent. Since the 5 doesn't look like it has one, I'm going to go ahead and give it an exponent of 1. Remember that an exponent just tells you how many of that thing you're looking at. So in situations like this, what I'm going to do is I'm going to take that 2 exponent and I'm going to distribute it to all of the other exponents inside. Not to the bases, but to the exponents themselves. So this is still going to remain a 5, but now I multiply the exponents 1 and 2. That gives me 2. The x stays the same. Multiply the exponents. That's going to give me 8. Last thing I need to do is actually compute 5 squared, which is 25. And then bring the x to the 8th with me. So whenever you have the exponent on the outside of a set of parentheses and there's no plus or minus signs inside, you can just go ahead and distribute them. So I'm going to use that same idea on example number 2. Everything that doesn't have an exponent, I'm going to go ahead and give it an exponent of 1. So the 3, the y, and looks like everybody else has an exponent. So let's go ahead and now distribute those. So this 2 exponent is going to go to everybody inside the parentheses that it belongs to, and this 3 exponent is going to go to everybody inside the parentheses that it belongs to. So let's go ahead and distribute those out. So the bases stay the same, and you multiply the exponents. Stays the same, multiply, and likewise. Now I'm going to get rid of the parentheses, so I think I'm just going to use a dot to represent multiplication. Let's go ahead and do the same thing with the second set of parentheses. Okay, now that we've gotten rid of the parentheses, let's go ahead and clean up that 3 squared, which is just going to be 9. Now, when you have multiplication like this, we want to put the common variables together, so everything that has the same base. And the idea is, how many do you have total now? So if I had x to the 8th and I put in another x to the 15th, I would have 23 total x's. So I'd be adding them together, or excuse me, adding the exponents. For my y's, I'd have a total of 11. Notice that I don't have any negative exponents. That's going to be my final answer there. Let's move on to number 3. With question number 3, whenever I have a division problem, there's actually a whole bunch of different ways that you can handle this. I think the way that I'm going to do this first is I'm going to simplify the 5 and the 20 because they're just plain old numbers, so I'm not going to do anything fancy with them. I know that 5 goes into each of those evenly, and I know that 5 goes into the top once, and 5 goes into the bottom 4 times. Notice that I extended my division bar because I'm not totally sure what's going to go on the top or what's going to go on the bottom just yet. Now, I want to do the exact same thing that I did before. However, I think I want to get all positive exponents to begin with. So the x to the 9th on the top has a positive 9th power, so let's go ahead and leave it where it is. So does the y squared that's already on the top. But that z to the 4th has a negative exponent, which means I need to change its location. It's in the top of a fraction, which means it needs to go to the bottom of the fraction to get a positive exponent. Now let's go back to the original question. Take a look at the ones on the bottom. I see an x to the negative 2. Well, I want it to be an x to the positive 2. So since it was in the bottom, I need to move it to the top. That y is just fine where it is. It's got a positive 1 exponent, or an exponent that I can't necessarily see. And then that z to the 4th. It's a positive 4th exponent in the bottom, so it's not a problem. We can just leave it where it is. All right, let's go ahead and use our properties of exponents now. And we can go ahead and use our subtraction. So, or actually we need to go ahead and combine. If you take a look at the top, I have 11 x's. And let's just bring everything with us. The y squared, onto the bottom I have 8 z's total and a y. Now it looks like the last thing I need to do is actually pull together my y's because I have y's top and I have y's bottom. So I've got to have an x to the 11th. If I subtract these two, it's going to be y to the 1, because it's 2 minus 1 on the bottom, and z to the 8th. This doesn't have any negative exponent, which means I'm fine. Let's go ahead and move on to question number 4. So it's much like the previous example, so let's go ahead and just get through this. Just like we did the previous problem, I see that the top and the bottom can both be divided by 6, so I'm going to go ahead and divide both of those by 6. It's going to give me a 1/3. Now, instead of moving things back and forth, I think I'm just going to go straight to the punch on this and use the property where, with exponents, I can go ahead and just subtract them if the bases match. So I take the top, and when you do this, you need to make sure that it stays in the top. So I've got an a. Now I'm going to take 9 minus the bottom exponent, which is -2. Then I'm going to do the same thing with b, top exponent minus bottom exponent. All right, so if I go ahead and clean this up, so there's my -1/3. If I put those two together, I'm going to get an 11th power, and then I get b to the 0. Well, this isn't quite done because you can't actually simplify b to the 0. Well, b to the 0 is just 1, so we can go ahead and get that out of there. And that's our solution for the fourth example. Fifth example, by far my favorite one. I don't necessarily want to do any work because if I take a look at this, the entire quantity is to the 0 power. Anything except for 0, any number other than 0 to the 0 power is just 1. So it doesn't really matter what it looks like inside. The answer is just 1.